Have you ever had a moment where time felt wrong? Maybe you blinked and an hour had vanished, or you woke up feeling like you had traveled through time, unsure if you had been asleep for minutes or centuries. Now, imagine that feeling, but on a cosmic scale. What if I told you that the universe itself is playing tricks with time and space, bending reality in ways that even the greatest scientists struggle to explain? What if black holes could freeze you in a moment forever, or entire stars could vanish as if they never existed? What if there were signals from the deep void of space, broadcasts that seem to come from nowhere, or perhaps from another time? For the next 3 hours, we are stepping into the unknown, into the mysteries of space-time that break every rule we thought we understood. We'll uncover stars that disappeared without a trace, space probes that were lost for years, only to reappear as if no time had passed. We'll dive into the eerie possibility that we might be living inside a cosmic illusion, a simulated universe where glitches and distortions hint at something or someone controlling it all. And the strangest part? These aren't just theories. These are real anomalies that astronomers, physicists, and astronauts have encountered. Events so bizarre that they challenge the very fabric of our reality. By the end of this journey, you might start questioning everything: time, space, even your own existence. But don't worry, because paradoxically, that's the key to understanding it all. So get comfortable, dim the lights, let go of what you think you know about the universe, because once you enter this realm of impossible cosmic mysteries, there's no going back. There are places in this universe that don't just test the limits of human knowledge, they mock them. Zones where logic breaks down, where spacecraft disappear without a trace, and where reality itself seems to flicker between what is known and what should be impossible. These regions are not myths, not folklore whispered by ancient civilizations, but places that have left seasoned astronauts baffled and mission control operators listening to static, wondering what just slipped through their fingers. A black void of uncertainty stretches before us, one that has swallowed entire missions, distorted instruments, and sent signals that do not belong to any human sender. Scientists have tried to explain these occurrences using gravity waves, cosmic radiation, and space-time distortions as potential culprits. Yet, for every answer they propose, new questions arise, like shadows that stretch just beyond the reach of light. There are cosmic regions where ships disappear, where astronauts report time behaving strangely, where navigational systems suddenly insist they are somewhere that should not exist. These cases are recorded not as myths, but as real moments of confusion and terror, logged by people trained to handle the cold rationality of space. There is no room for superstition in the vacuum of the cosmos, only data, only cold, hard readings. And yet, when the instruments fail, when entire probes are swallowed, when voices are heard in transmissions long after their sources should have been destroyed, even the most skeptical minds hesitate. Something is happening out there, and we are going to step into the mystery. The Bermuda Triangle is infamous on Earth, a region where planes and ships have vanished under bizarre circumstances. But what if there was a Bermuda Triangle beyond our planet? A region in the void where objects, time, and even reality itself seems to slip through unseen cracks? A cosmic space where astronauts have witnessed distortions with their own eyes, where ships have vanished without explanation, and where something, perhaps something watching, waits on the edges of our understanding. In the darkest corners of the universe where human eyes rarely look, secrets are buried deep in the fabric of time itself. There are zones where spacecraft enter, but never return. Probes that go silent, only to reappear in impossible locations years later, as if time had stopped for them. There are astronauts who have reported shifts in space that should not happen, entire regions of nothingness bending, changing, or momentarily ceasing to exist. One of the most disturbing anomalies was first observed by Russian cosmonauts who found their instruments behaving erratically in a certain region of orbit. At first, it was dismissed as a minor failure, a glitch, a temporary software issue. But as time went on, reports started piling up from different missions. Pilots in deep space reported their coordinates shifting inexplicably, their guidance systems sending them in circles as if space itself had been altered. Some missions recorded their time-tracking devices losing seconds, then minutes, then entire blocks of recorded data. The universe does not skip time, yet here, something was breaking that rule. A deep space probe sent into the region in the late 1990s vanished for nearly a decade. The final transmission was nothing more than distorted static. For years, astronomers assumed the probe had been destroyed, collided with debris, lost power, or been pulled into an unseen gravitational field. Then, one morning, the probe's signal re-emerged. It was broadcasting as if nothing had happened. The coordinates were checked. The probe had returned from an unknown location, entirely intact. But the strangest part? Its internal systems showed no time had passed. The data logs, the memory banks, the radiation readings, all indicated that the probe had never stopped functioning. As far as its onboard computer was concerned, no missing years had occurred. A spacecraft disappearing is strange enough. But what happens when something disappears and then returns, untouched by time? Reports from astronauts in the early days of space travel detail encounters with strange distortions in the fabric of reality. Men and women, trained for precision and logic, have described seeing flashes of movement where none should exist. In one account, a mission en route to the moon recorded an object tailing them, an object that moved in ways impossible by known physics. It flickered in and out, appearing miles ahead one moment, then suddenly behind them the next. No other spacecraft were reported in the area. No debris, no natural phenomenon explained the event. When the astronauts attempted to document it, their cameras malfunctioned. When they attempted to radio it in, their communication lines crackled with unknown interference. They were left with nothing but their own memories. When they landed, the recordings from their instruments showed only gaps, time that had been recorded and then lost. This was not an isolated event. There is a place near the outer edge of the solar system where spacecraft routinely go missing, where their transmissions fail for inexplicable reasons, where their final signals come distorted, and where, in rare cases, their signals return years later, carrying echoes of voices that should not exist. Some scientists believe that this region, much like the Bermuda Triangle on Earth, could be home to some form of natural anomaly, perhaps a gravitational distortion, an unstable pocket of warped space-time. Others argue that the missing spacecraft could have fallen victim to hidden forces we have yet to understand. One of the most chilling reports came from a space mission intended to study deep space radiation. The astronauts were conducting a standard equipment check when one of them noticed something unusual outside the viewing window, a distant object, a structure of some kind, barely visible against the endless blackness. At first, they assumed it was a distant asteroid, a shadow, or a trick of light. But as they continued to observe it, the structure did something impossible. It vanished, not by moving, not by speeding away, but by simply ceasing to exist. It had been there, and then it was not. The astronauts attempted to report what they had seen, but their transmission was interrupted by an unknown signal, a signal that lasted exactly 7 minutes and 13 seconds before cutting out completely. When they reviewed the recording later, the audio contained nothing but an eerie, rhythmic pulse. This was not the first time such a signal had been recorded in that region of space. Even before the age of manned space travel, astronomers had noted areas in space where signals vanished, where telescopes failed to track objects that should have remained visible. Some of the earliest radio transmissions received from deep space came from locations that now seem to be entirely empty. The sources of those signals, stars, pulsars, or possible distant planets, are no longer there. It is as if they existed at one moment and the next had been erased from history. Perhaps the most unsettling part of these disappearances is not the absence of explanation, but the eerie sense that something, some unknown force, is at work beyond our understanding. Time should not behave this way. Space should not allow for objects to be lost and then found again as if nothing had happened. And yet, the records exist. The missions that have gone silent, the astronauts who returned home unable to explain what they saw, the instruments that fail in specific regions without reason. These things are real. The Bermuda Triangle of space may be an unseen rift in our universe, a doorway to another dimension, or something even more profound, a reminder that the cosmos does not belong to us, that we are merely visitors in a world we barely understand. What if some of these missing objects, these lost transmissions, these unexplained anomalies, what if they are not accidents? What if they are part of something larger? And more disturbingly, what if something is watching? There are few things in the universe more terrifying than the loss of control, the feeling that something beyond human understanding has gripped reality, twisting it into a shape that defies logic. The Bermuda Triangle of space has left astronauts and scientists shaken, their instruments failing them, their sense of time and space unraveling in ways they cannot explain. But what if time itself is not as steady as we assume? What if the seconds ticking on a clock are not universal, but personal, warped by forces so vast they bend the very essence of existence? The idea that time flows evenly, predictably, from past to future is one of the greatest illusions of human perception. Time is not a constant. It bends, it stretches, and in some cases, it nearly stops. The deeper one ventures into space, the clearer this becomes. To move through the universe is to experience time differently, not as a steady rhythm, but as something fluid, something that speeds up and slows down based on where you are and how fast you are moving. A mission to space is not just a journey through distance, but a journey through time itself. Astronauts who leave Earth and travel at extreme speeds return having aged differently than those who stayed behind. What is only a few months for them may be years for those on the ground. Scientists have measured this effect with atomic clocks on airplanes, satellites, and space stations, proving that time does not behave the same way for everyone. This is not science fiction or a theoretical paradox. It is reality, dictated by the laws of physics. Albert Einstein's theory of relativity shattered the idea that time is absolute. Instead, time stretches and compresses depending on gravity and velocity. The closer one gets to a massive celestial body, the slower time moves. The faster one travels, the more time warps around them. If a spacecraft were to approach the event horizon of a black hole, its crew would experience moments while the rest of the universe surged forward by centuries. To an outside observer, they would appear frozen in time, trapped in a moment that may never end. Deep space is filled with regions where time does not flow as expected. Near massive stars, where gravity is overwhelming, the passage of time slows to a crawl. A spacecraft orbiting such a body for what seems like days may return to find that decades have passed elsewhere. The closer one gets to the core of a neutron star, the more time itself warps, stretching seconds into years. This is not speculation. It has been observed. One of the most unsettling discoveries in modern physics is that time dilation does not only occur in the extreme conditions of deep space, it is happening to everyone, everywhere, all the time. Those living at higher altitudes experience time slightly faster than those closer to sea level. Satellites in orbit, moving at high speeds, must constantly adjust their clocks to stay synchronized with Earth. If time was truly universal, these corrections would not be necessary, but they are. The implications of this are unsettling. If time is not a fixed quantity, then it is possible for two people experiencing different gravitational forces to live in the same universe while aging at entirely different rates. An astronaut traveling near the speed of light could return to Earth only a few years older, while centuries had passed on the planet. If such a journey were made, the astronaut would find themselves in an unrecognizable world, everyone they knew long gone, history rewritten by the passage of time they did not experience. The laws of relativity suggest that the closer one gets to the speed of light, the slower time moves. If a spacecraft could travel at 99% the speed of light, its crew would experience only a fraction of the time that passed for those they left behind. A mission that took only 5 years for them might mean 500 years had passed for everyone else. The idea that one could step into a ship and leave behind not just a planet but an entire era is no longer fiction. This effect becomes even stranger near the most extreme objects in the universe, black holes. The gravitational pull of a black hole is so intense that it warps not just space but time itself. A clock placed near the event horizon would slow to a near standstill when compared to one far away. If an observer watched a spacecraft approach a black hole, they would see it slow down, taking longer and longer to reach the edge until it appeared frozen in place. Yet, for the crew inside, time would still feel normal. They would continue moving, unaware that to the rest of the universe, they were trapped in a moment that could last forever. Astronomers have observed stars in the process of falling into black holes, their light stretched and slowed until it becomes invisible. To those stars, the process may take only moments. To us, it appears frozen, a ghostly record of something that happened long ago, still visible because time near the event horizon no longer flows in the way we understand. The possibility that time can nearly stop raises disturbing questions about the nature of existence itself. If a person could be trapped in time near a black hole, would they ever truly be lost? Would they simply remain in a moment, forever on the edge of falling, while the rest of the universe moved on without them? The idea of using time dilation for space travel is not just theoretical. If humans ever venture beyond the solar system, they will encounter time in ways that defy their experience. A trip to a nearby star, moving at a significant fraction of light speed, would mean that the crew would return home to an Earth that had changed beyond recognition. One of the most haunting aspects of time dilation is the realization that different regions of the universe are aging at different rates. Some galaxies, caught in the grip of supermassive black holes, are experiencing time more slowly than others. There are stars that, from our perspective, seem to be in their infancy, yet to observers within them, billions of years have already passed. The universe is not experiencing time as a single event. It is fragmented, broken into regions where time flows differently, stretching and contracting in ways that defy intuition. Time is not what we think it is. It is not a river that flows at the same speed for everyone. It is a shifting, malleable force, dependent on motion and gravity, capable of stretching eternity into a second or slowing a moment into infinity. The deeper we explore the universe, the more we realize that our perception of time is nothing more than a convenient illusion, one that fails under the vast, inescapable weight of cosmic reality. There are astronauts who have already felt the effects of time dilation, those who have lived aboard the International Space Station, moving at speeds of 28,000 kilometers per hour, have aged slightly less than those on Earth. The difference is tiny, fractions of a second, but it is real. In the future, when missions push further, when humans set foot on planets orbiting extreme gravitational forces, those differences will become more pronounced. If an astronaut spent a year on a planet orbiting a black hole at just the right distance, they could return to find that thousands of years had passed elsewhere. The history of their home world would be rewritten. They would have stepped into the future, not through artificial means, but through the raw, inescapable laws of physics. The unsettling part of time dilation is that it implies an unavoidable truth. Time is not equal for everyone. Some people, in some places, are living their lives faster than others. If an astronaut left Earth today and returned in a century, they might experience only a few years while the world moved on without them. For those left behind, it would be as if they had disappeared into the abyss, only to return from the depths of history. The passage of time is not a straight line. It bends, it warps, and in some cases, it can nearly stop. The deeper we push into the universe, the more we realize that time is as much a force as gravity itself, one that can be manipulated, stretched, and, in the most extreme cases, stolen away entirely. As the universe continues its endless expansion, as galaxies drift apart, as black holes devour light and time, one truth remains undeniable. No two people, no two places are experiencing time the same way. What is a moment for one might be an eternity for another. What is an eternity for one might pass in the blink of an eye for someone else. Time is not universal. It is personal. And the deeper one falls into the mysteries of the cosmos, the more it becomes clear that it is not time that moves. It is us. Time does not flow the way most people think. It stretches, bends, and in some places fractures entirely. Astronauts moving at extreme speeds age slower than those left behind. A person standing near a black hole would experience seconds while centuries pass for everyone else. Some galaxies are frozen in time from our perspective, while others race ahead, aging faster than the laws of physics should allow. These distortions in time are not hypothetical. They have been observed. They shape the universe itself. But there is something even more unsettling than the warping of time. There are messages. For decades, scientists have pointed their instruments toward the sky, listening to the silent hum of space. But silence is not what they found. Instead, scattered throughout the vastness of the cosmos are signals, strange pulses of radio waves, bursts of energy, transmissions that seem to originate from nowhere. Some of these signals repeat like clockwork. Others come once and are never heard again. A few follow no logical pattern at all, as if they were not meant to be understood. One of the most disturbing discoveries in radio astronomy was the realization that some signals arrive on Earth from places where no known stars or planets exist. They emerge from voids, regions of space where nothing should be. The universe is vast, but it is not random. Everything follows patterns, orbits, and rules dictated by gravity and time. When a transmission arrives from empty space, it raises questions that should not need to be asked. What is broadcasting from the darkness? What force is bending the laws of physics to send messages through the abyss? Some signals have an unsettling property. They appear to have traveled through time itself. There are bursts of radio waves that, when analyzed, suggest they originated billions of years ago, long before Earth even existed. Yet somehow, they arrive fresh, as if they had been sent only moments ago. The distances involved are impossible to comprehend, stretching across entire cosmic epochs. The light from some of the oldest galaxies takes billions of years to reach us, yet some of these signals seem immune to that limitation. They cross the void at impossible speeds, or perhaps bypass the normal flow of time altogether. One of the most famous of these transmissions was recorded in 1977. A radio telescope scanning deep space picked up a signal so powerful and so precise that it stood out against the usual background noise of the universe. It lasted 72 seconds, then stopped. The signal never returned. Scientists tried to locate the source, scanning the same region again and again, but nothing was there. The signal became known as the WOW signal, named after the handwritten note an astronomer left on the data printout. It defied explanation. It had the characteristics of an artificial transmission, deliberate, structured, and incredibly strong. But no known source, natural or otherwise, has ever been found. There are other signals, some stranger than the WOW signal, some even more perplexing. In 2012, astronomers detected a fast radio burst that lasted only milliseconds, but carried the energy of millions of suns. It came from a distant galaxy, yet its structure suggested something far more complex than any known astrophysical event. The most disturbing part? The same burst was detected again and again from the same location. Unlike the WOW signal, this one repeated. No known natural phenomenon explains it. The bursts come without warning, following no discernible pattern. Some theories suggest that these signals are the echoes of cosmic events, black holes colliding, neutron stars merging, the remnants of ancient explosions. But others suggest something far more unsettling. If time does not behave the way we think it does, if the fabric of the universe allows for distortions and folds, then perhaps these signals are not from the past, but from the future. A civilization that mastered time might not send messages through space in the way humans do. Instead of launching physical probes, they might transmit information directly through the fabric of reality, sending bursts of data backward through time itself. A species millions of years ahead of humanity might communicate in ways that defy linear progression. What we perceive as strange, out-of-place signals could be fragments of a greater conversation, one we are incapable of understanding. There are signals that do not just defy location, but meaning itself. Some seem to follow a structure, mathematical, almost intelligent. Others fluctuate randomly, as if corrupted by some unknown interference. The human brain is wired to seek patterns, to make sense of randomness. When a person stares at static long enough, they start seeing shapes. When they listen to noise, they begin to hear voices. But what if just once the noise is real? The universe is old, far older than anything the human mind can truly grasp. Civilizations may have risen and fallen long before Earth was even formed. If they sent messages into space, those messages would still be traveling, drifting endlessly through the void, waiting for something or someone to hear them. Some astronomers have speculated that the eerie, repeating pulses of radio waves known as pulsars were once mistaken for alien signals. The first detected pulsar was nicknamed LGM-1, short for Little Green Men. It was later understood to be a rapidly spinning neutron star, but the idea remains. How can we be sure that some of these signals are not truly artificial? There are frequencies that seem to appear and vanish without reason. Some signals fade in and out, as if they are being obscured by something unseen. Others accelerate, bending their wavelengths in ways that should not be possible. Scientists have recorded bursts of energy that appear to shift their properties depending on when they are observed, as if they are not fixed in place but moving through dimensions beyond human comprehension. A disturbing question lingers. If there are signals reaching Earth from deep space, is it possible that something or someone is receiving signals from us? Radio waves travel outward indefinitely, spreading like ripples in a pond. Every television broadcast, every radio transmission, every encoded satellite pulse ever sent from Earth is still moving, drifting into the vastness of space. Some of those transmissions have already traveled hundreds of light years, If an intelligent species exists within that range, they might already be listening. There is a theory that civilizations do not broadcast their presence intentionally. If the universe is as ancient as it seems, and if intelligence is rare, then perhaps other species learned long ago that making noise is dangerous. Some scientists propose the dark forest theory, named after the idea that space is like a vast dark forest, where every civilization is a hunter, hiding in silence, fearing that any sound might bring something far more powerful upon them. If this is true, then the signals Earth has been receiving might not be random at all. They might be warnings. In 2015, astronomers detected a signal so strange it defied classification. It came from a star system unlike any other, a place where the brightness of the star fluctuated in ways that no natural process could explain. Some scientists speculated that the fluctuations might be caused by an immense artificial structure, possibly a Dyson sphere, a megastructure built to harness the energy of an entire star. The theory remains speculative, but the signals persist. If something is out there, it may be far older and far more advanced than humanity could ever comprehend. The vast distances involved mean that even if these signals are from intelligent beings, they may be long gone. The time it takes for radio waves to travel means that whoever sent them may have vanished millions of years ago. What we hear now could be the remnants of a civilization that no longer exists, their last words drifting through the void long after their world turned to dust. The search for extraterrestrial intelligence has been met with skepticism, but the signals keep coming. Some are explained: cosmic radiation, natural pulsars, distant quasars, but others remain unanswered, waiting for an explanation that may never come. Scientists continue to listen, scanning the sky for transmissions that break the silence of space. There is no guarantee that we will ever understand what we are hearing. Some signals may never be decoded, their meaning forever lost. Others may be waiting for the right moment, the right mind, to recognize them for what they are. The universe is speaking. The question is whether anyone is ready to listen. Time does not behave the way most believe. It stretches, contracts, and occasionally shatters entirely. The strange signals from deep space, the distortions in the flow of time, and the disappearance of entire celestial bodies all point to a reality that does not follow the rules we assume it should. The deeper we investigate the mysteries of the cosmos, the more cracks begin to show, as if the universe itself is revealing a hidden layer beneath the surface. There is something unnerving about the idea that reality is not fundamental, that what is seen, heard, and felt is merely an interface, like a screen displaying information rather than the information itself. The more physicists study the laws that govern the universe, the more they begin to resemble code, structured, precise, and suspiciously efficient. If the universe were truly infinite and natural, randomness should dominate. But what is observed is the opposite. Patterns emerge where there should be chaos. The large-scale structure of the universe, the way galaxies cluster together, the way matter distributes itself, follows an eerily mathematical framework, one that looks less like an organic formation and more like something designed. The deeper one looks into the quantum world, the stranger reality becomes. Particles do not exist in fixed states until they are observed. Their properties are uncertain, fluctuating between possibilities until measurement forces them into a defined form. If reality were fundamental, this should not be the case. Instead, it behaves as if it is being rendered on demand, only displaying what is necessary in a given moment. Some of the most compelling evidence comes from the limits of physics itself. There exists a smallest possible unit of distance, known as the Planck length, beyond which space ceases to have meaning. Similarly, there is a smallest possible unit of time, Planck time, suggesting that time too is quantized, not continuous. In a truly natural universe, No such limits should exist. But in a program system, resolution limits are necessary. Computers do not generate infinite detail. They create only what is required for the user to perceive continuity. The speed of light, long considered the ultimate speed limit of the universe, behaves suspiciously like a processing constraint. No matter how fast an observer moves, light remains constant relative to them, as if the universe is enforcing a maximum refresh rate. If the universe were simulated, this would make perfect sense. One of the strangest clues comes from black holes. According to quantum physics, when information enters a black hole, it should be destroyed. But this would violate one of the most fundamental principles of physics, that information cannot be lost. To resolve this paradox, some scientists propose that the information is not lost, but instead stored on the surface of the black hole in a way that suggests it behaves like a hologram. The implications of this are profound. If information is not lost in a black hole, then it suggests that the entire universe itself may be encoded onto a distant boundary, a cosmic projection rather than a physical space. This is the foundation of the holographic universe hypothesis, the idea that what is perceived as three-dimensional reality is actually encoded on a two-dimensional surface at the edge of the observable universe. Some of the most advanced research in string theory supports this idea. The mathematics used to describe black holes works more elegantly when treated as a holographic projection rather than a traditional three-dimensional object. If this applies to black holes, there is no reason it could not apply to the entire universe. There are cosmic anomalies that further support this unsettling theory. The cosmic microwave background radiation, the afterglow of the Big Bang, contains fluctuations that appear strangely uniform, as if the universe were designed to have a set resolution, much like a computer-generated image. In a natural universe, these fluctuations should be more random. The presence of this order suggests an underlying structure, one that hints at an artificial nature. Another disturbing observation comes from the behavior of cosmic rays, high-energy particles that travel through space at near-light speeds. Some experiments have found that these particles behave as though they are interacting with a hidden grid, a fundamental lattice of space-time itself. In a simulation, this would be expected. Just as pixels define the resolution of a screen, space itself may be composed of discrete points rather than a smooth continuum. If reality is a simulation, the next question is, why? Is it an experiment, a test, a creation for entertainment? Theories range from the mundane to the extraordinary. Some propose that an advanced civilization, perhaps even a future version of humanity, created the simulation to study their own history. Others suggest it is an artificial construct designed to test intelligence, to see if beings within the system could discover its true nature. Perhaps the simulation is not for human benefit at all. It could be part of a computational process far beyond human understanding, running for purposes unrelated to the simulated inhabitants. If a superintelligence had access to infinite computational resources, entire universes could be generated as easily as running a simulation on a computer. One of the most unsettling implications of the simulation hypothesis is the question of what happens if the simulation ends. In human-created virtual environments, processes can be terminated at any time. If the universe is artificial, then it follows that its creators could shut it down at any moment. Some scientists have even suggested that abrupt cosmic events, such as unexplained bursts of energy or rapid changes in the laws of physics, could be evidence of a system update or a reset. There are philosophical implications as well. If the universe is a simulation, does free will exist? If reality is predetermined by programmed laws, then human consciousness may simply be part of the system, following a script without true autonomy. Yet some argue that discovering the simulation itself is an act of free will, that intelligence within the system has the ability to recognize its artificial nature and, in doing so, break free of its constraints. For centuries, mystics and philosophers have described reality as an illusion, a veil over something deeper. Ancient spiritual traditions speak of a world that is not as it appears, of a hidden truth that lies beyond ordinary perception. Modern physics is beginning to suggest the same. The more science uncovers about the nature of the universe, the more it aligns with these ancient ideas. Experiments are underway to test whether reality has fundamental limits, whether there are artifacts of a computational structure hidden in the fabric of space-time. Some researchers are examining high-energy interactions, searching for evidence that reality has a processing delay. Others are studying quantum mechanics to see if particles behave differently when they are not being observed, if they follow the logic of a programmed simulation rather than a physical universe. The idea that the universe is a simulation is not merely science fiction. It is a hypothesis taken seriously by some of the world's leading physicists, including those working at the cutting edge of quantum mechanics and cosmology. If true, it would mean that everything known about existence is an illusion, one so convincing that even the greatest minds in history have only begun to question it. The deeper one looks, the more reality reveals itself to be something else entirely. The laws of physics may not be fundamental, but imposed. The structure of the universe may not be natural, but programmed. And the events that seem to occur randomly may not be random at all. If the universe is a simulation, then the final question is the most disturbing of all. What lies beyond it? And who or what is watching? If reality itself is an illusion, if the universe is a programmed construct following rules that mimic computation, then what happens when something goes missing? Not because of an explosion, not because of a slow, measurable decay, but because it is simply erased, removed from existence as if it had never been there in the first place. The deeper scientists probe into the mysteries of the cosmos, the more they encounter events that should be impossible. If reality follows strict physical laws, then there should be a clear reason for every celestial change. But there are stars that have vanished, not collapsed, not drifted beyond detection, but disappeared without any trace, leaving nothing behind. A missing star is not just an absence of light. It is a direct contradiction of everything that should be possible in astrophysics. Stars follow a predictable life cycle, moving through stages of birth, growth, and eventual decay. When a star reaches the end of its lifespan, it does not simply blink out of existence. It either collapses into a black hole, explodes in a supernova, or fades over billions of years. Yet astronomers have documented cases where stars once catalogued in astronomical records no longer exist. There is no remnant, no lingering radiation, no evidence that they were ever there. One of the most unsettling discoveries came when researchers compared historical sky maps with modern astronomical surveys. In dozens of cases, stars that were recorded in the past were missing from contemporary data. These were not faint or barely visible objects. They were significant celestial bodies, observed and documented. Yet, in some regions of the sky, nothing remains. No dust cloud, no trace of a collision, no evidence of gravitational displacement. This phenomenon raises disturbing questions. If stars can disappear, what is removing them? Some theories suggest these objects may have undergone transformations that are beyond current understanding. Others propose that unknown cosmic forces, perhaps related to dark matter or exotic physics, are at play. But the most unsettling possibility is that the missing stars were not naturally erased, but were deliberately removed. The idea that the universe could be edited is no longer confined to speculation. If reality operates on programmed rules, then an entity capable of manipulating those rules could theoretically erase objects from existence. This would mean that missing stars are not simply anomalies, but evidence of an unseen force modifying the cosmos in ways that defy human perception. One of the most famous cases of a missing celestial object occurred in 1952, when astronomers catalogued a bright star in a specific region of the sky. It was observed multiple times, its position recorded, and its brightness measured. Yet, when later observations were conducted, the star was gone. The region of space where it had been located was empty. Further scans revealed no remnants, no stellar debris, no gravitational lensing, no disruption in the surrounding cosmic fabric. It was as if the star had never existed. This case was initially dismissed as an observational error, but as more similar disappearances were recorded, skepticism turned into genuine concern. Stars do not simply vanish. The energy they produce, the gravitational influence they exert, should leave some evidence of their existence. But in these cases, there was nothing. Some astronomers proposed that extreme black hole activity might be responsible, that a black hole could have consumed the star so completely that no light escaped. But this explanation does not hold up. Even in the case of a black hole devouring a star, the process is visible. It produces immense energy, detectable radiation, and gravitational distortions. In the case of the missing stars, none of these indicators were present. A leading hypothesis is that some stars are shifting into dimensions beyond human perception. Theoretical physics suggests that there may be hidden layers to reality, higher dimensional spaces that exist beyond the observable universe. If a celestial body were to shift into one of these dimensions, it would vanish entirely from view, leaving behind no trace. There is a growing belief that these vanishing stars might be linked to dark matter, the invisible substance that makes up the majority of the universe's mass. Some scientists speculate that dark matter could interact with normal matter in ways not yet understood. If a star were caught in a sudden dark matter anomaly, it could be drawn into an alternate state of existence, no longer interacting with light and therefore becoming invisible to observation. But there is an even more unsettling possibility. Some missing stars have vanished from regions of space where unexplained signals have been detected. These are the same regions where unknown radio bursts, fast-moving cosmic anomalies, and other irregularities have been recorded. If something is happening in these sectors of the universe, it may not be natural. A few radical theories propose that the missing stars could be connected to extraterrestrial activity. If an advanced civilization had the ability to manipulate cosmic structures, they might be capable of dismantling a star, extracting its energy, or relocating it entirely. The concept of a Dyson sphere, a massive artificial structure built around a star to capture its energy, has long been theorized. If such a civilization existed, it might have the ability to move entire stars across space or consume them in ways that leave no observable evidence. A few missing stars have been observed in patterns that suggest an underlying design. In certain regions, multiple disappearances have occurred in alignment, forming geometric shapes across vast cosmic distances. While this could be coincidence, it raises the question of whether these disappearances are part of something greater, an unknown process shaping the fabric of the cosmos according to a blueprint that is beyond human comprehension. The phenomenon of missing stars also ties into unexplained gravitational distortions. In some cases, astronomers have detected gravitational anomalies in regions where no visible matter exists. This suggests that something massive is present, something exerting force on the surrounding space, but it cannot be seen. These distortions may be the gravitational remnants of vanished stars, or they could be evidence of something even stranger, a process that removes celestial bodies from observable reality while leaving behind their gravitational influence. In a universe where time does not behave as expected, where space itself can bend and shift, the disappearance of stars may be linked to broader cosmic phenomena. Some astrophysicists speculate that these stars are not being destroyed, but are slipping into alternate versions of the universe, parallel realities where their presence continues, undisturbed. If such a process is occurring, it would imply that the universe is far more complex than previously believed. The notion that reality could branch into multiple outcomes with objects moving between them suggests that what is seen is only a fraction of what truly exists. One of the most haunting aspects of these missing stars is that their absence forces a reevaluation of what it means to exist. If something as massive as a star can be erased without a trace, then permanence itself may be an illusion. The universe, which seems so vast and unchanging, may instead be fluid, constantly shifting, rewriting itself in ways that are only now beginning to be noticed. There are still no definitive answers. The study of missing stars is in its infancy, with researchers attempting to track down more cases, analyze historical data, and compare notes across different observatories. But one thing is certain: something is removing stars from the sky. Whether this is a natural process that has yet to be understood, a force outside of known physics, or an intelligence acting on a scale beyond human comprehension remains unknown. If the cosmos is a programmed reality, a simulated construct following hidden rules, then the disappearance of stars could be evidence of an update, a restructuring of the system. In human-created simulations, objects are removed when they are no longer needed. If the universe operates under similar principles, then what is being erased, and why? As more cases emerge, the possibility that the cosmos is far stranger than ever imagined becomes harder to ignore. If stars can vanish without explanation, then what else could disappear? What else has already been erased, unnoticed? And if the process is continuing, then at what point does the erasure reach the level of entire galaxies, entire civilizations? If something is removing stars, then the final question is the most unsettling of all. Who decides what stays? And what happens when it is our turn? If stars can vanish without a trace, if entire celestial objects can be erased from the fabric of reality, then the question must be asked: what if existence itself is not as linear as it seems? What if the universe does not move forward in a straight path, but instead folds back on itself, repeating events with eerie precision? For as long as humanity has recorded the cosmos, there have been signs that something strange is occurring at the deepest levels of reality. Stars that should have been destroyed seem to reignite. Cosmic structures, separated by billions of years, appear identical as if they are echoes of each other. Some regions of space contain celestial formations that should be unique, yet, upon closer inspection, they match other formations in distant corners of the universe, as though reality itself is mirroring its own design. One of the most unsettling discoveries in astrophysics is the behavior of pulsars, rapidly spinning neutron stars that emit beams of energy in rhythmic pulses. These cosmic lighthouses rotate with astonishing precision, their pulses acting like natural cosmic clocks. But in certain cases, pulsars have been observed exhibiting a phenomenon that defies explanation. They reset. A pulsar will spin for thousands of years, its rhythm as stable as the laws of physics allow, until, without warning, it begins emitting signals identical to those it sent in the distant past. Scientists who track these pulsars have found entire sequences of pulses that match those recorded from the same star centuries ago, as if time within that region has restarted, replaying events exactly as before. This raises an unnerving possibility. What if time does not flow as an uninterrupted current? What if certain events, on both a cosmic and a personal scale, are not progressing forward, but instead cycling, caught in loops of repetition? There are theories that the universe, at its most fundamental level, is structured not as a linear sequence of moments, but as a series of repeating patterns, an endless recursion of events that play out again and again, only to reset when the cycle is complete. Astronomers have noted cosmic formations that resemble each other so closely that by statistical probability they should not exist in the same universe. Galaxies separated by billions of light-years exhibit identical structures, down to the arrangement of their stars. Some physicists propose that these are not merely similar formations, but the same galaxies seen in different cycles of cosmic time. If the universe operates under a looping mechanism, then everything within it, stars, planets, and even life itself, may be playing out scenarios that have already happened and will happen again. The déjà vu phenomenon, experienced by countless individuals throughout history, may be more than a mere trick of memory. Some researchers believe it could be a result of the human mind briefly syncing with a reality that has already played out before. If time loops exist at the cosmic level, affecting galaxies and stars, there is no reason they could not also affect consciousness itself. Astronauts who have spent extended periods in space have reported strange lapses in perception, moments where they feel as though they have already lived through certain experiences. Unlike normal déjà vu, these moments are often accompanied by a deep, almost instinctual certainty that something is cycling, that time is not moving forward, but instead retracing its steps. Some astronauts have described looking out at the cosmos and feeling as though they had already seen the exact same view, in the exact same moment, long before their mission had even begun. There are physical anomalies that suggest time may not be progressing uniformly across the universe. Some regions of space seem to contain structures that defy their expected age, stars that should have long since burned out but remain inexplicably active, planets that should be younger but exhibit geological features that imply billions of years of history. If the universe is caught in loops, resetting itself in ways not yet understood, then these discrepancies could be evidence of reality reloading, as if an unseen mechanism is returning everything to an earlier state. Quantum mechanics has long hinted at the possibility that time does not function the way it appears at larger scales. Particles behave unpredictably, sometimes appearing to reverse their states as though moving backward in time. The famous delayed choice experiment suggests that actions taken in the present can retroactively affect outcomes in the past. If reality itself allows for the past and future to influence each other, then time loops may not be a rare anomaly, but an intrinsic feature of the cosmos. A more unsettling idea emerges from the field of thermodynamics. The second law of thermodynamics states that entropy, the measure of disorder in a system, should always increase over time. But certain observations have suggested localized regions where entropy seems to reverse, as though time itself is rewinding. This has led some theorists to propose that the universe undergoes cycles of collapse and rebirth, not as a single event, but as a constant repetition, resetting itself endlessly. If this is true, then every moment, every decision, every action may have already happened countless times before. Individuals living their lives may not be doing so for the first time. They may be experiencing the same reality again and again, with only minor variations each cycle. Some versions of this theory suggest that loops are not universal but selective, affecting only certain events or individuals. There are documented cases of people surviving catastrophic accidents in ways that defy probability, falling from great heights without injury, walking away unharmed from destruction that should have been inescapable. These anomalies raise the question of whether some people are caught in localized loops, reliving moments that should have ended differently. There are places on Earth where time itself seems to behave irregularly. Some locations, often linked to electromagnetic disturbances or gravitational anomalies, have been reported to induce time slips, events where individuals experience the sensation of being momentarily displaced from the present. If these locations exist, they may be physical points where the fabric of reality folds back on itself, creating pockets of repeated time. At the largest scale, the question arises, if the universe is caught in a loop, then what governs its reset? Some physicists believe that the expansion of the cosmos will eventually reverse, causing the universe to collapse in on itself before being reborn in a new cycle. Others propose that the reset is not physical, but informational, that the fabric of reality itself periodically restores itself to an earlier configuration, like a system rebooting after running for too long. The most unsettling implication of the time loop hypothesis is the idea that individuals may have already lived this life before, countless times. If time cycles endlessly, then every thought, every decision, every failure and triumph may be an echo of something that has already happened and will happen again. Some philosophers and scientists speculate that if time loops are real, then the only way to break free from them is to become aware of the cycle itself. If an individual were to recognize the pattern, to consciously remember what has happened before, then they might find a way to step outside of the repetition, breaking the cycle and entering a different state of existence. The growing body of evidence for time loops suggests that reality may be far stranger than anyone has ever considered. If the same cosmic events are playing out again and again, then existence is not a straight path but a circle, one that humanity has been walking for eternity. There are no definitive answers, only more questions. If the universe is repeating, then the past is not gone, and the future has already happened. If time is looping, then what does it mean to move forward? And if reality is caught in an endless cycle, then the final question remains the most unsettling of all. If time is caught in loops, if cosmic events are endlessly repeating, then there must be places where time itself begins to break down entirely. Places where the laws of physics no longer apply, where past and future dissolve into something unrecognizable. There is one type of celestial object in the universe where time is no longer a steady force, where the very fabric of reality collapses into itself. Black holes are the final threshold, the point where space and time lose all meaning. They are not merely objects. They are the edges of existence, the doorways to something unknown. A black hole is not just a region of extreme gravity. It is a wound in the structure of the cosmos, a place where matter and time are no longer separate. Everything that crosses the event horizon, the invisible boundary surrounding a black hole, is forever cut off from the rest of the universe. Light itself is unable to escape. Time, as experienced by an outside observer, slows to a near halt, creating the illusion that anything falling in is frozen just before crossing the threshold. Yet for the object itself, the experience is different. Time continues normally from its own perspective, as if it is falling through space like any other object. The nature of black holes suggests that the universe is far more complex than previously understood. They challenge the idea that time flows in only one direction. In the presence of extreme gravity, time is stretched and warped, meaning that different observers will experience events in ways that contradict each other. A person falling into a black hole would see the universe beyond them speed up, racing toward the far future as they descend toward the singularity. To those outside, the falling object would appear to slow down indefinitely, never quite reaching the center. These contradictions reveal the deeper instability of time itself. One of the strangest properties of black holes is their ability to erase information. According to conventional physics, information cannot be destroyed. Everything that happens leaves an imprint on the universe. Yet black holes consume matter and energy, swallowing their information without any known mechanism to retrieve it. This paradox, known as the black hole information problem, remains one of the biggest unsolved mysteries in physics. Some theories propose that information is not lost, but instead encoded on the event horizon itself, creating a holographic imprint of everything that has ever fallen in. If this is true, then black holes are not merely destructive, they are cosmic archives, storing the history of the universe in a form that is unreadable to anyone outside. The implication is staggering. If black holes store information on their surface, then it suggests that reality itself may be structured in a similar way, that everything within the universe is nothing more than a projection from a deeper layer of reality. There is also a growing belief that black holes are not just endpoints, but gateways. Some physicists propose that the extreme warping of space-time near a black hole could create bridges, wormholes connecting distant points in space, or even links to other universes. The equations of general relativity do not forbid such possibilities. If wormholes exist, then black holes may not be one-way traps, but tunnels leading to places outside the observable universe. The idea that black holes could lead to alternate realities is supported by the mathematics of quantum mechanics. When matter collapses inside a black hole, it does not merely vanish. It enters a state where conventional physics ceases to function. Some theories suggest that instead of being crushed into a singularity, matter transitions into a parallel space, existing in a form that cannot be perceived from the outside. If this is true, then black holes are not voids, but cosmic doorways, leading to regions of space-time where different laws apply. The concept of time itself is altered inside a black hole. While time slows near the event horizon for an outside observer, it does something even stranger for someone who crosses the threshold. Once inside, the very direction of time flips. What was once forward motion becomes an inescapable pull toward the singularity. From the perspective of the falling object, time no longer exists as a separate dimension. It becomes a force dragging everything toward the core, merging space and time into a single, irreversible trajectory. The singularity itself remains an enigma. It is a point where gravity is infinite, where the equations of physics collapse into meaningless values. Some physicists believe that singularities do not truly exist, that they are merely the result of incomplete theories. Others suggest that singularities are real but hidden, shielded from the rest of the universe by the event horizon. If singularities do exist, they may hold answers to the most fundamental questions about the nature of reality. One of the more unsettling theories suggests that black holes are not only cosmic erasers, but cosmic creators. Some physicists propose that the intense compression of matter inside a black hole could give rise to a new universe, forming a new space-time region entirely disconnected from our own. This would mean that every black hole could be the seed of a new cosmos, expanding beyond its singularity into a reality beyond human comprehension. If this is the case, then the question arises, could our own universe have been born from a black hole? Some cosmologists believe that the conditions of the early universe bear striking similarities to the physics of black hole interiors. If true, then existence itself may be an endless cycle, with each universe giving birth to new ones through the formation of black holes, each containing an entire cosmos within. There are also theories that black holes may not be entirely separate from the rest of the universe. Some research suggests that black holes slowly leak energy, a process known as Hawking radiation, named after physicist Stephen Hawking. Over time, this radiation causes black holes to evaporate, eventually disappearing entirely. The question remains, what happens to everything that was inside? If information is truly conserved, then some unknown mechanism must exist to preserve it, even as the black hole vanishes. The most disturbing possibility is that black holes represent the final fate of time itself. If the expansion of the universe eventually slows, and if all matter collapses into black holes, then the future may hold a reality where nothing exists except event horizons, vast, empty voids where time has stopped entirely. Some theories suggest that this state may be a necessary reset, that once the universe reaches its end, the trapped energy within black holes will be released, triggering the birth of a new cosmos. There is also the possibility that black holes serve as cosmic barriers, preventing anything that falls inside from affecting the larger universe. If advanced civilizations exist, and if they have mastered the ability to manipulate space-time, they may have discovered ways to use black holes as tools, perhaps as energy sources, or even as controlled gateways to other regions of existence. Some physicists believe that if intelligent life ever achieves complete mastery over physics, black holes may become the foundation of their technology used to manipulate time itself. The implications of black holes extend beyond astrophysics. If reality is structured in a way that allows for infinite gravity wells, then it suggests that existence is far more flexible than previously assumed. If black holes contain universes, if they serve as pathways to other dimensions, then the cosmos may be layered, containing levels of reality beyond human perception. The final question remains: what happens to time beyond the event horizon? If time no longer behaves in a predictable way, then what does it mean to exist inside a black hole? Some theories suggest that an object crossing the event horizon does not simply move forward in time, but instead experiences all moments at once, compressed into an infinite singularity where past, present, and future cease to be separate. The nature of black holes challenges the very foundation of human understanding. They are not simply massive gravitational wells. They are ruptures in the fabric of space-time, regions where the universe itself behaves in ways that defy comprehension. They may be prisons, they may be gateways, or they may be the seeds of new realities waiting to emerge. Whatever black holes truly are, one thing is certain: they are not just objects in space, they are places where time itself reaches its limit. And beyond that limit, anything may be possible. If black holes mark the end of time, if they are the places where reality collapses into something unknown, then what lies beyond them? What if there are regions of space not filled with extreme gravitational forces, but with something even more unsettling? Nothing at all? Not the vacuum of space, which still contains energy, particles, and the remnants of distant radiation, but true emptiness, a void so absolute that it should not exist. The universe is not supposed to have gaps. Matter is not randomly scattered, but follows an intricate pattern shaped by gravity and time. Galaxies form clusters, stretching in great threads across the cosmos, bound together by invisible forces. Between them are pockets of lower density, but even in these spaces, something should exist: floating dust, drifting atoms, or at the very least, dark matter, the unseen mass that shapes the universe's structure. Yet, there are places where nothing exists at all. These voids, spanning hundreds of millions of light years, are not mere empty spaces between galaxies. They are vast cosmic deserts where the normal rules of astrophysics break down. They are not regions of low density. They are regions of non-existence. There is no dust, no detectable radiation, no measurable gravity from hidden mass. They appear as cosmic anomalies, defying every model that predicts how the universe should be structured. One of the largest and most perplexing voids ever discovered is the Bermuda void, a vast, seemingly endless stretch of emptiness nearly 330 million light-years across. If the universe followed expected patterns, this region should contain thousands of galaxies. Instead, it holds barely a handful, scattered like lost remnants in an ocean of nothingness. The void is not simply a lack of stars. It is a break in the cosmic web, a missing piece in the fundamental design of reality. Cosmologists struggle to explain how such an absence could have formed. Gravity should have pulled matter into these regions over billions of years, yet the void remains untouched. Some theories suggest that extreme cosmic forces, such as dark energy, may be pushing matter away from these zones, creating expanding pockets of nothingness. Others propose that these voids are remnants of an earlier phase of the universe, regions where matter was erased or never formed at all. There is an even more unsettling possibility. Some researchers believe that these voids are not natural, but are instead evidence of something missing from cosmological equations, regions where the universe itself may not exist in the same way it does elsewhere. If space-time is structured like a cosmic lattice, then these voids may be areas where the fabric of reality is thinner, places where existence itself has worn away. If true, then these voids may be more than empty spaces. They may be cosmic holes, gaps in the structure of reality, places where the laws of physics weaken or break entirely. Some have speculated that they could be linked to unknown dimensions, that they are doorways into something beyond the observable universe. The existence of voids raises troubling questions about the fate of the cosmos. If these regions are expanding, then it suggests that, over time, matter is being pushed out, leaving behind more nothingness. If this process continues, it could mean that the universe is not evolving toward greater complexity, but toward erasure, that given enough time, everything will drift apart, leaving only infinite silence. Dark matter, the mysterious substance that makes up most of the universe's mass, is absent from these voids as well. This is significant because dark matter is expected to be everywhere, shaping galaxies and holding them together with its invisible force. The fact that these voids lack even this unseen mass suggests that they are not simply empty, but fundamentally different from the rest of the universe. There is a hypothesis that these voids may not be voids at all, but something entirely beyond current understanding, regions where space itself behaves differently. Some physicists propose that within these voids, the fundamental constants of nature may be altered. If true, then these areas are not merely missing matter. They are separate realms with their own rules, isolated pockets of a universe that operates on principles no human mind has yet conceived. A few theories propose that these voids are the aftermath of ancient cosmic events, massive, unknown forces that swept through the universe, clearing matter from these regions like an invisible tidal wave. If such events occurred, then they suggest the presence of cosmic-scale influences that have yet to be detected. Some even speculate that these voids could be the scars of something more artificial, a restructuring of space itself, evidence of an intelligence capable of manipulating reality on a scale beyond comprehension. One of the most perplexing features of voids is their effect on light. When photons travel through these regions, they do not behave as expected. Some appear to be subtly stretched, while others seem to shift in frequency in ways that do not match gravitational models. These irregularities suggest that voids are not passive spaces, but active distortions, places where the very medium of space-time is behaving differently. If voids are expanding, then it raises another unsettling question. Are they consuming the universe? If there is an unknown force at work, pushing matter away from these regions, then it suggests that space itself is being rearranged, that something is exerting influence over the cosmos in ways not yet understood. One possibility is that voids are connected to the larger mystery of dark energy, the unknown force driving the accelerated expansion of the universe. If dark energy is responsible for pushing galaxies apart, then it may also be responsible for the growing size of these voids. But if dark energy is increasing over time, then the universe may be heading toward a state where voids become dominant, where matter becomes nothing more than isolated islands in an ever-expanding sea of emptiness. Some physicists suggest that voids are linked to quantum fluctuations on an unimaginable scale. If reality is built from quantum interactions, then these voids may represent regions where those interactions have weakened or broken down, creating gaps where the normal processes of space-time do not function. If this is true, then these voids may not simply be places of missing matter, but of missing reality, zones where the fundamental structure of existence has failed. The presence of such vast cosmic voids challenges the idea that the universe is structured in an organized, predictable way. If there are areas where the rules no longer apply, then the question must be asked, what is keeping the rest of the universe from dissolving into similar nothingness? If these voids continue to grow, then eventually the cosmic web itself may unravel, leaving behind a universe in which structure no longer exists. One of the strangest possibilities is that these voids are not empty at all, but simply beyond current detection methods. Some theories propose that they may contain forms of matter or energy that are completely outside the known laws of physics. If such entities exist, then they may represent an entirely separate aspect of reality, one that interacts with the universe in ways not yet understood. If these voids are unnatural, if they were created rather than formed through cosmic evolution, then the implications are staggering. It would suggest the presence of something capable of restructuring the cosmos itself, of carving out regions of non-existence for purposes beyond human comprehension. If such an entity exists, then it is operating on a level so far beyond human understanding that its presence is only noticed through the absence it leaves behind. There is no consensus on what these voids truly are or why they exist. Some see them as natural features of an evolving universe, regions where matter simply never accumulated. Others believe they are evidence of unknown cosmic forces, hints at a deeper layer of reality that has yet to be uncovered. But one thing is certain, these voids should not exist. They defy expectations, challenge predictions, and raise questions that have no easy answers. If they continue to expand, if the process responsible for them is ongoing, then the final question becomes clear. Are we looking at the future of the universe? And if so, what happens when the last traces of matter are finally consumed by the nothingness? If the universe contains regions of absolute nothingness, places where even the structure of reality seems to vanish, then what happens in the places where existence itself slows to a crawl? Time is not a fixed, unchanging flow. It bends, stretches, and in certain parts of the cosmos, it all but stops. There are locations where seconds stretch into eternity, where events that should have happened long ago are still unfolding, frozen in cosmic slowness. If space can be distorted, then so can time. And if time can be altered, then the entire nature of existence is far more fluid than it seems. The deeper one moves into the vastness of space, the stranger time becomes. Gravity, speed, and unknown cosmic influences warp its passage, creating regions where time moves at different rates depending on where an observer stands. There are places where time accelerates, moving faster than expected, and others where it slows, causing events that should have played out long ago to linger indefinitely. Some objects seen through telescopes today may not even exist anymore, their light only now reaching observers because time has been stretched so severely in their region of space that their past lingers far beyond its natural limit. One of the most well-documented ways time slows is through the immense gravitational pull of massive celestial objects. A clock placed near a black hole will tick slower than one further away. This is not an illusion, but a fundamental feature of reality. Time is bound to space, and when space itself is curved by gravity, time follows. The deeper something falls into a gravitational well, the slower its experience of time becomes relative to the rest of the universe. The effect of gravitational time dilation has been observed in extreme cases, such as stars orbiting close to black holes. These stars, moving at high velocities through intense gravitational fields, experience time differently than those further away. To an outside observer, the light from these stars appears stretched, as if the events unfolding near them are happening in slow motion. If someone were able to stand on the surface of one of these stars and look outward, they would see the rest of the universe racing forward, distant galaxies aging at a pace they could not comprehend. One of the most unsettling implications of this effect is that for anything that crosses the event horizon of a black hole, time effectively stops from an outside perspective. A falling object, once past the threshold, never appears to reach the singularity. It seems frozen at the edge, stretched across infinite time. Yet for the object itself, time continues normally. The contradiction exposes the deep strangeness of time. It is not a universal experience, but something that depends entirely on perspective. High velocity also alters the passage of time. Objects moving near the speed of light experience time at a slower rate than those at rest. This is a direct consequence of relativity, a feature of space-time that has been experimentally confirmed. Astronauts traveling at high speeds age slightly less than those on Earth, a measurable effect that has been recorded through precise atomic clocks. The faster an object moves, the greater the time distortion, to the point that at speeds approaching the speed of light, time nearly stops. If a spacecraft could somehow reach such speeds, its occupants would experience time at a fraction of the rate of those left behind. A journey across the galaxy could take a few years for those on board, while thousands or even millions of years would pass outside. If they returned, they would find themselves in a future unrecognizable, with entire civilizations risen and fallen in the span of their own brief experience. The idea that time itself is flexible, that it stretches and contracts depending on motion and gravity, raises unsettling questions. If the universe is filled with regions where time moves at different rates, then what is the true age of the cosmos? The age of the universe is often measured based on the light that reaches Earth. But what if there are places where time has been stretched so severely that events that should have ended billions of years ago are still unfolding? The phenomenon of cosmic time dilation is not just theoretical. It has been observed in distant supernovae, the exploding deaths of stars. Light from these events reaches Earth stretched and slowed, indicating that time moved differently in those regions. The deeper one looks into the universe, the more pronounced these effects become. Some galaxies appear frozen in states they should have long since evolved out of, suggesting that their regions of space are caught in a slowed flow of time. One of the strangest implications of time dilation is that it suggests the universe is not experienced the same way everywhere. If different regions of space move through time at different rates, then reality itself is fractured. There may be places where the events of the past are still playing out, galaxies caught in an endless moment, unable to progress at the same speed as the rest of the cosmos. If time is not a steady force, then what determines its rate? Gravity and velocity explain much, but some anomalies suggest there may be other forces at play. Some regions of deep space appear to be locked in strange distortions where time moves unpredictably, neither entirely frozen nor completely normal. These areas are difficult to study, as their effects can only be inferred from the way light and matter behave within them. One theory proposes that unknown cosmic forces, possibly linked to dark energy, are responsible for some of these time distortions. If dark energy is accelerating the expansion of the universe, then it may also be stretching time itself, creating areas where time flows unevenly, disconnected from the larger cosmic progression. Another possibility is that time dilation is connected to the structure of space itself. If the universe is composed of layers or dimensions beyond human perception, then time may not be a simple forward-moving force, but something that interacts with these deeper structures. Some researchers speculate that time may be influenced by interactions with hidden dimensions, creating pockets of slowed reality where normal physics does not apply. If time can slow and stretch, then it raises the possibility that time itself is something that can be controlled. If a civilization were advanced enough to manipulate gravity at will, they could theoretically slow their own passage of time, extending their existence indefinitely. Some have speculated that intelligent life, if it has mastered the mechanics of space-time, may have positioned itself within regions of extreme time dilation, living in a slowed state where millions of years pass in the outside universe, while only decades pass within their controlled region. The presence of time dilation also suggests that human perception of time is extremely limited. If consciousness itself is bound to the flow of time, then it means awareness is a product of the environment in which it exists. If one were to step into a region of slowed time, perception itself might be altered, with thoughts stretching into seemingly endless moments. The slow-motion universe is not an abstraction. It is a reality that exists in the fabric of space-time. Everything that moves is affected by it, yet it remains imperceptible in everyday experience. But for those who venture far enough into the depths of space, for those who cross the boundaries where time begins to fail, the universe does not appear as a steady, predictable place. It becomes something much stranger, a reality where moments can stretch across eternity, where entire civilizations could rise and fall while a single traveler experiences only a brief passage of time. If time can slow to a near halt, if reality itself can stretch across endless moments, then what happens when objects traveling through space simply disappear? What if the machinery we send into the void does not simply fail, but instead ceases to exist for a time, vanishing from all detection, only to return as if nothing had changed? There are spacecraft that have done exactly this. Probes that stopped transmitting, their signals lost in the silence of deep space, only to reawaken years or even decades later, responding as if no time had passed. Machines do not sleep, yet some of humanity's most advanced robotic explorers have done just that. They have gone dark, vanished into the abyss of space, and against all odds, returned. These are the interstellar ghost ships, lost space probes that have seemingly defied time itself. One of the most unsettling cases is the Pioneer anomaly. Pioneer 10 and Pioneer 11 were among the first spacecraft to journey beyond the planets of the solar system, launched in the 1970s to explore the outer reaches. As they drifted into the depths of interstellar space, something strange happened. Their trajectories did not match predictions. They were slowing down, ever so slightly, in ways that could not be accounted for by known physics. Decades of calculations could not fully explain the anomaly. These were not simple deviations. These spacecraft were experiencing forces that should not exist. But even stranger are the probes that have vanished entirely, their signals ceasing abruptly, only to return without explanation. One such case is that of NASA's IMAGE satellite. Launched in 2000, it was designed to study Earth's magnetosphere. For years, it transmitted valuable data, until one day, it stopped. All attempts to re-establish contact failed. It was declared lost. Then, in 2018, nearly 14 years later, an amateur astronomer detected a signal coming from deep space. It was IMAGE, transmitting as if nothing had happened, as if no time had passed. How does a machine designed to function under precise conditions, simply stop working and then resume years later. Theories range from simple system failures to far stranger possibilities. Some suggest that image encountered an unknown cosmic phenomenon, something that disrupted its systems in a way beyond current understanding. If deep space is filled with distortions in time, with gravitational warps and electromagnetic anomalies, then these spacecraft may not have been truly inactive. They may have been caught in something humanity has yet to comprehend. Even more disturbing are cases where spacecraft have gone missing in regions of space associated with other unexplained phenomena. The Voyager probes, launched in 1977, have continued to transmit data from the edge of interstellar space, but they too have experienced unexplained disruptions, moments where their signals have weakened, distorted, or been briefly lost. These moments coincide with their passage through cosmic regions that are not fully understood, places where the influence of the sun's gravity and radiation gives way to the larger forces of the galaxy. Some researchers speculate that these missing and reappearing probes have encountered time dilation effects on a scale that alters their very function. If the passage of time can change in different parts of space, then what seems like a malfunction could instead be a probe moving through a region where time does not behave normally. If a spacecraft were to pass through a slow time region, it might experience an interruption that from its perspective never occurred, returning to normal function as soon as it leaves that zone. There is also the question of the unknown signals. Throughout history, space agencies have detected transmissions that defy explanation. Radio waves and signals appearing where none should exist. Some of these signals have later been identified as natural cosmic phenomena, but others remain unsolved. In certain cases, lost probes have returned just as strange signals were detected, leading to speculation that they may have encountered something or someone beyond human understanding. Some of the most famous lost probes include those sent to study Mars, Venus, and the outer planets. The Soviet Union's Phobos 2, launched to study Mars' mysterious moon Phobos, ceased contact just as it was about to transmit data from its final approach. The last signal received from the probe included an inexplicable shadow on the Martian surface, something that did not match the known geography of the planet. Shortly after, all communication was lost. Phobos 2 never responded again. Other probes have disappeared for reasons that cannot be fully explained by engineering failure alone. In 1993, NASA's Mars Observer was approaching the red planet when it suddenly went silent. Every attempt to re-establish contact failed. The probe was never recovered, and no definitive explanation for its loss was found. Then there are the anomalies surrounding deep space transmissions. Probes that should have been lost forever have occasionally sent back brief, fragmented signals long after their expected operational lifespans. These signals do not always contain intelligible data. Some are nothing more than sudden bursts of static or irregular frequency pulses, but their existence suggests that something is happening in deep space, something that interferes with machines in ways that remain unknown. There are theories that some of these anomalies may be linked to gravitational distortions caused by unseen cosmic forces. If space-time itself is not uniform, then spacecraft may encounter pockets where the rules of physics shift unpredictably. These regions could act as traps, slowing time, scrambling transmissions, or even temporarily displacing objects before allowing them to return to normal space. Some have even proposed that certain spacecraft may not have returned at all, but instead, something else came back in their place. If a probe were to pass through an unknown region of space, interacting with forces beyond human comprehension, would it still be the same probe when it reappeared? Could something alter its internal systems, its programming, or even its structure in ways that scientists cannot yet detect? These questions remain unanswered, but what is certain is that the phenomenon of disappearing and reappearing probes is not a simple technical failure. Some cases can be explained by mechanical malfunctions, but others defy easy categorization. If time itself is flexible, if space contains unknown forces that warp reality, then these interstellar ghost ships may be more than lost machines. They may be evidence that the universe is not as stable as once believed. Even now, new probes are being launched into the unknown, carrying humanity's instruments deeper into the cosmos. Some of them will transmit for decades, faithfully reporting back their findings. Others may disappear, their signals swallowed by the silence of deep space. The question is, will they stay gone? Or will they, like those before them, return, carrying secrets from regions of the universe that no human has ever seen? If these lost probes have encountered something in the void, then the final question is the most unsettling of all. If probes can vanish into space only to reappear as if time had never moved, if spacecraft can lose all connection to reality and then return as if nothing happened, then what else is slipping through the cracks of the universe without detection? What if entire sections of reality are shifting, rearranging themselves in ways that no one notices, except for the faintest echoes in human memory? If objects, events, and even celestial formations are not fixed, but subject to unseen forces, then the very fabric of reality may be more fluid than previously believed. The question is no longer just about space probes, but about the universe itself. Could it be that what is remembered is not always what truly was? There are countless moments when people recall something that seems to no longer exist, from historical events unfolding in ways that contradict widely accepted facts to astronomical features that seem to have changed without explanation. Some of these discrepancies are dismissed as misremembering, but others are too consistent, too widespread to ignore. When large numbers of people recall the same detail differently from what is recorded in history, it is often labeled as the Mandela effect, a phenomenon in which collective memory appears to contradict documented reality. But what if it is more than a trick of the mind? What if these inconsistencies are symptoms of something deeper, evidence that reality itself is shifting, that the universe is not as stable as it seems? There have been reports of astronomical phenomena that appear to change without any known cause. Some constellations, which should remain fixed for thousands of years, have been observed behaving strangely, their formations subtly shifting in ways that do not align with natural cosmic drift. Some stars that were once catalogued have disappeared, not in the usual way by going supernova or fading out, but simply ceasing to exist in any known record. Some astronomical objects have appeared unexpectedly, as though they had always been there, but had somehow slipped through unnoticed. One of the most puzzling anomalies in astrophysics is the unexplained shifting of the cosmic background radiation, the afterglow of the Big Bang. The distribution of this radiation should remain constant, but subtle, unaccounted for fluctuations have been recorded over the years. Some scientists attribute these changes to better measurement tools, but others believe they may hint at something more mysterious, potential evidence that the structure of reality itself is altering over time. There is also the enigma of deep space observations that do not match past records. Some galaxies have been documented with structures that seem different from previous images, as though something has altered their shape. Some distant celestial bodies appear in locations where they should not be, either moving in unexpected ways or seemingly shifting between observations. The question arises, are these errors in measurement, or is there something happening on a grander scale? One of the more perplexing aspects of this phenomenon is that it extends beyond astronomy and into human experience. If the universe is shifting in ways that are barely perceptible, then the human mind itself may be registering these changes without fully understanding them. People report remembering details of events that seem to have altered, not just in minor ways, but in ways that fundamentally contradict recorded history. These are not mere inconsistencies in knowledge. They are persistent memories of a world that no longer seems to exist. Some physicists have theorized that if reality is influenced by quantum mechanics, then the universe itself may not be a single, fixed timeline, but something more flexible. If quantum states exist in superposition, then on a large scale, reality itself may also exist in multiple states at once. What if, rather than shifting gradually, reality occasionally undergoes abrupt changes, adjustments that affect everything, but leave only traces of their occurrence in the minds of certain individuals? If the universe operates on a principle of probabilities, then there may be moments when one version of events overtakes another. Certain quantum models propose that every decision, every interaction at the smallest level has the potential to create a branching effect, splitting reality into different outcomes. If this occurs on a cosmic scale, then entire sections of space-time could be adjusting, not as a gradual process, but as instant transitions between states. This would explain why some individuals retain memories of things that seem to have been erased from existence. If consciousness itself is in some way connected to the structure of reality, then awareness may act as an anchor, holding on to memories from previous versions of reality even when everything else shifts. One of the more unsettling aspects of this theory is that it raises questions about the stability of reality. If what is remembered does not always align with what is recorded, then how many times has the universe already changed? If these shifts are happening constantly, then history itself may be fluid, reshaped in ways that are only noticed by those who retain fragments of past versions. There are many cases where people recall information that does not match the present. Some recall geographic features that seem to have changed locations. Others remember scientific facts differently from what is now taught, even though they were once considered widely accepted. Some recall books, films, and even historical events playing out in ways that contradict their current form. One of the most striking examples of this is in the field of cosmology. Some individuals recall descriptions of the Milky Way galaxy that differ from current astronomical models. Some recall certain planets being positioned differently, moons that were once known but no longer documented. Could it be that reality itself has been edited in ways that defy detection, except through these lingering memories? The most unsettling question is whether these shifts are natural or deliberate. If the universe has an underlying structure that occasionally resets, then it may simply be a function of space-time adjusting in ways not yet understood. But if these changes are being guided, then the implications are staggering. It would mean that something, some force, intelligence, or mechanism is altering reality itself, erasing and replacing aspects of the universe as it progresses. Some have speculated that these shifts are connected to the deeper fabric of space-time, that they are not random but are instead moments where reality is aligning with a larger, unseen structure. If space is not a singular entity, but a part of a much broader multiverse, then these changes may represent shifts between different versions of reality, subtle adjustments where fragments of alternate timelines occasionally overlap. There is also the possibility that these shifts are not limited to space, but extend into human perception itself. If consciousness is in some way entangled with the structure of the universe, then shifts in reality may leave traces in the form of altered memories. If time, space, and awareness are interconnected, then these anomalies may not just be occurring in the cosmos, but within the very fabric of thought itself. These lingering discrepancies, these contradictions between memory and recorded fact, point to a reality that is not as fixed as it appears. If the universe can shift, If the past itself can be rewritten in ways that only a few notice, then the most profound question remains unanswered. Is the world that exists now the same one that existed yesterday? Or have we already moved into a different version of reality without even realizing it? If reality itself can shift, if fragments of the past can dissolve and be replaced without explanation, then what force is responsible for holding the universe together at all? If timelines flicker and galaxies subtly change, then what is keeping everything from spiraling into chaos? There is something unseen, something vast and incomprehensible that governs the universe on scales too great to fully grasp. It does not emit light, nor does it interact with matter in ways that can be directly detected, yet it shapes everything. It binds galaxies, distorts time, and bends space itself. Dark matter and dark energy are not just theoretical constructs, they are the silent architects of existence. They do not merely affect gravity, they may influence time itself, warping its passage in ways that remain undetected by conventional measurements. They are the hidden forces that shape reality, determining the motion of entire galaxies while remaining invisible to every instrument designed to find them. If there is an underlying structure to time and space, then dark matter and dark energy may be the unseen hands guiding it. Galaxies do not rotate the way they should. If only visible matter governed their motion, their outer edges would drift apart, unbound by gravity. Yet something unseen holds them together, something providing the mass needed to prevent them from flying into the void. This invisible substance, labeled dark matter, does not emit or reflect light, but it exerts an undeniable gravitational pull. It is woven into the very fabric of the cosmos, forming an unseen web that dictates the structure of the universe. But what if dark matter does more than hold galaxies together? What if it influences time itself? Gravity is known to affect time, stretching and slowing it near massive objects. If dark matter has gravitational effects strong enough to bind galaxies, then it may also be distorting time in ways that remain unmeasured. The passage of time could vary depending on the density of dark matter in a given region of space. This would mean that different parts of the universe are not just moving at different speeds, but are experiencing time at different rates. There are regions of space where time appears to flow inconsistently, places where galaxies behave as though they are caught in some unseen distortion. Some astronomers have noted discrepancies in the ages of stars, with certain regions appearing older or younger than they should be based on cosmic expansion. If dark matter interacts with time, then it may explain why these anomalies exist, why some celestial bodies appear frozen in time while others seem to have accelerated beyond expected limits. Dark energy, the force driving the accelerated expansion of the universe, is even stranger. It is not simply pushing galaxies apart, it is stretching space-time itself. The more the universe expands, the more dark energy seems to grow, as though it is feeding off the very fabric of space. If space is expanding, then time may be expanding with it. This could mean that time is not a fixed dimension, but something that fluctuates along with the growth of the cosmos. There are theories suggesting that dark energy is not merely a repulsive force, but a form of anti-gravity, something that counteracts the normal flow of time. If dark energy is increasing, then its effect on time may be increasing as well, gradually altering the way moments unfold. This could mean that the universe is not simply expanding, but evolving in ways that alter the perception of time itself. One of the most perplexing observations in modern physics is the apparent existence of galaxies that seem to be moving faster than they should be, not because of their motion through space, but because space itself is being stretched. Some have proposed that this stretching is not uniform, that certain regions of the universe experience greater temporal distortion than others. If this is true, then time itself may be expanding unevenly, creating pockets where its passage differs from the cosmic average. There is also the possibility that dark matter and dark energy are not separate forces but aspects of the same phenomenon, two sides of a deeper reality that has yet to be uncovered. Some theories suggest that what is perceived as dark matter may actually be a form of hidden time, a structure within the universe that interacts with the passage of events on a level beyond current understanding. If dark matter exerts a gravitational pull without being visible, then it may exist in a state that does not fully conform to known dimensions. Some physicists speculate that dark matter could be leaking in from higher dimensional space, exerting an effect on reality without fully existing within it. If this is true, then the gravitational distortions attributed to dark matter may also be influencing time, creating areas where temporal flow is altered by interactions with unseen dimensions. One of the most intriguing possibilities is that dark matter may act as a kind of scaffolding for time itself. If time is not a separate force but a manifestation of space, then the structure of dark matter may determine how it unfolds. This could explain why time does not move at a constant rate throughout the universe, why some regions seem to experience it differently than others. There are also strange gravitational anomalies observed in certain parts of the cosmos, places where the movement of celestial objects does not align with expected models. Some of these anomalies have been linked to dense concentrations of dark matter, but others have no known explanation. If time is affected by dark matter, then these distortions may be more than simple gravitational irregularities. They may be evidence of regions where time is warping in response to unseen forces. Another theory suggests that dark matter and dark energy may not be independent at all, but are instead manifestations of a hidden cosmic cycle. If the universe undergoes periodic shifts, then dark energy may be the driving force behind these transitions, altering the very structure of time as it expands and contracts. If this cycle is ongoing, then the flow of time itself may not be steady, but may fluctuate in response to these cosmic adjustments. There is also the question of whether dark matter and dark energy could be manipulated. If they influence gravity, time, and space, then an advanced enough civilization could, in theory, learn to control them. If time can be slowed, accelerated, or even stopped under the right conditions, then the manipulation of dark matter and dark energy may hold the key to unlocking the deepest mysteries of existence. Some speculative models suggest that dark energy may not be expanding the universe in a continuous process, but in discrete steps, causing sudden jumps in cosmic structure. If true, then these shifts could be responsible for the unexplained phenomena observed in deep space, the missing stars, the galaxies that appear older than they should be, the strange distortions that seem to warp the fabric of reality itself. If time is not a constant, if its flow is influenced by forces beyond direct observation, then the entire understanding of reality may be incomplete. Dark matter and dark energy remain among the greatest mysteries in physics, yet their influence is undeniable. If they are responsible for the large-scale structure of the universe, then they may also be shaping time in ways yet to be discovered. There is one final question that lingers, one that challenges the foundation of physics itself. If dark matter and dark energy are shaping time, then what existed before them? If time is not fixed, then does it have an origin, or has it always been changing, shifting, warping under the influence of forces beyond human comprehension? If dark matter and dark energy shape time in ways beyond human comprehension, then what happens to objects that move through the cosmos without a fixed path? What if celestial bodies, bound by gravity yet seemingly unbound by conventional time, do not always behave as expected? The universe follows laws of motion that should be predictable, yet there are anomalies that defy every calculation. Some objects seem to slip through the cracks of time itself, appearing, vanishing, and reappearing in ways that should not be possible. Among the strangest of these anomalies are comets that do not obey the rules. Comets are expected to follow highly elliptical orbits, predictable loops through space that allow astronomers to determine when they will return. Some take only a few years to complete their journey, while others take centuries. Yet there are comets that behave in ways that contradict everything known about orbital mechanics. Some reappear too soon, moving faster than physics should allow. Others vanish entirely, failing to return on schedule, only to emerge much later, sometimes in locations that defy expectations. A few have even appeared out of nowhere, as if they had never existed before. One of the most famous cases of a comet behaving in an unexplained manner is that of Comet Halley. This celestial traveler has been documented for over 2,000 years, its return predicted with increasing accuracy over time, but early records suggest that its orbit was once different, its trajectory shifting in ways that cannot be entirely explained by gravitational interactions. There are accounts of it arriving earlier than expected, as if time itself had altered its course. Some astronomers have speculated that unknown forces, perhaps linked to dark matter, gravity distortions, or even temporal shifts, may be affecting its motion in ways yet to be understood. Even more perplexing are the cases of comets that simply disappear. Some have been tracked for years, their return carefully calculated, only for them to never arrive. These are not cases of simple fragmentation or collisions with other objects. These comets appear to have been erased from existence. When later searches are conducted, no remnants are found. It is as though they have been removed from time itself. Then there are the comets that do return, but not where or when they should. Some have reappeared in entirely different orbits, as if they had traveled through a path unknown to conventional physics. There are records of comets that have re-emerged centuries later than expected, moving as if no time had passed for them. Others have shown signs of temporal distortion, appearing with characteristics that suggest they have not aged in the way they should have. If time affects everything equally, then why do some objects seem exempt from its flow? One theory suggests that certain comets may be interacting with regions of space where time behaves differently. If dark matter creates gravitational anomalies, then it may also create time distortions that affect objects passing through. A comet that enters one of these regions could experience time at a different rate, allowing it to re-emerge either sooner or much later than expected. If time is not uniform throughout space, then these celestial wanderers may be moving through unseen corridors where the rules of reality shift. Some physicists have proposed that comets may occasionally pass through pockets of space where gravity does not behave as expected. If these pockets exist, they could create acceleration effects that alter a comet's trajectory, speeding it up in ways that would otherwise be impossible. There are even more radical theories that suggest comets may interact with hidden dimensions, areas of space where time flows at an entirely different rate, allowing them to temporarily vanish before re-entering normal space at a later point. There are also unexplained cases where comets have shown erratic changes in brightness, as if something were interfering with their physical composition. Some have gone dark, becoming nearly invisible before suddenly reigniting with unexpected luminosity. Others have displayed signs of fragmentation, only to later appear fully intact. If comets are being affected by forces beyond gravitational influences, then what else could be acting upon them? Another anomaly involves the sudden increase in velocity of some comets, a phenomenon that does not match expected gravitational influences. Some have accelerated in ways that defy predictions, moving faster than should be possible given their known mass and trajectory. While some of these cases have been attributed to gas outbursts or sublimation effects, others remain unexplained. If time is being manipulated at certain points along their journey, then their apparent acceleration may not be movement in space, but a distortion in time itself. One of the more unsettling possibilities is that certain comets are not simply moving through space, but are instead slipping through different states of reality. If space-time contains weak points, then these objects may be temporarily moving through alternate versions of the universe before returning. This would explain why some reappear in places that contradict known physics, as if they had taken a route through something other than the standard three-dimensional structure of space. There have also been recorded cases of comets that have seemingly reversed their trajectory, moving against expected orbital mechanics. While some of these reversals can be attributed to interactions with gravitational fields, others cannot be so easily explained. There are records of comets that have switched orbits in ways that do not match any known gravitational influence, behaving as if they were being acted upon by something unseen. Some astronomers have also reported comets with highly unusual rotational patterns, objects that appear to spin in ways that defy known physics. If comets were simple balls of ice and rock, their rotational motion should be predictable. Yet some have displayed sudden changes in spin rates, as if external forces were exerting pressure upon them in ways that are not currently understood. There is also the question of whether some comets are disappearing due to factors entirely beyond gravitational influence. If time itself is not stable, then objects moving through certain regions may be subject to distortions that cause them to temporarily slip out of existence. A comet that appears to disappear may not have been destroyed, but instead may have moved through an unseen time shift, one that placed it outside normal observation before allowing it to return. The existence of such anomalies raises unsettling questions about the nature of time and space. If even relatively small celestial bodies can be affected in ways that defy expectations, then what does this imply for larger cosmic structures? If time can shift for a comet, then could entire regions of space be undergoing similar distortions? Could stars, planets, or even galaxies be experiencing the same fluctuations on a much larger scale? The most intriguing question of all is whether these anomalies are random or part of a larger, structured pattern. If there are forces influencing the movement of celestial bodies in ways beyond current understanding, then they may be acting according to principles that have yet to be uncovered. Some physicists have even proposed that such anomalies could be signs of hidden cosmic mechanisms, unseen structures that dictate the motion of objects in ways not yet accounted for by modern physics. There is no single explanation that accounts for all of these phenomena. Some anomalies may be due to interactions with dark matter, others with gravitational distortions, and some may be linked to effects that remain entirely unknown. But the undeniable truth is that these anomalies exist, that the cosmos contains mysteries far beyond what has been mapped or predicted. The final question is whether these comets are giving humanity a glimpse into something deeper, a process or force that governs the universe on a fundamental level. If time is not fixed, if objects can move through space in ways that defy standard physics, then what else is slipping through the cracks of reality? If comets can warp time, then what happens when larger celestial bodies begin to do the same? If celestial objects can slip through time, if their trajectories defy physics, if the universe itself bends reality in ways not yet understood, then what happens when something unnatural is found drifting in the void? If comets and planets can experience time distortions, then what of objects that do not belong to any known cosmic structure? There are things in space that should not be there, anomalies that suggest intelligence, technology, or forces far beyond human comprehension. The universe is ancient, filled with events spanning billions of years, and if intelligent life has ever existed beyond Earth, then traces of it may still be out there, waiting to be discovered. There have been reports of objects in deep space that do not conform to natural celestial formations. These are not simply rocks, asteroids, or planetary debris, but something more: structures, geometric shapes, or anomalies that suggest artificial origins. Some have theorized that these may be relics of past civilizations, remnants of advanced technology that once traversed the stars but now float abandoned, unnoticed by all but the most careful observers. If time-warping technology exists, then these artifacts may be the key to understanding it, providing glimpses into knowledge beyond human capability. One of the most perplexing anomalies in astronomy is the detection of structures that appear to be engineered rather than naturally formed. Among these are objects that reflect light in ways inconsistent with known materials, as if they possess surfaces designed for purposes unknown. Some have displayed behaviors that defy expectations, changing trajectory in ways that do not match gravitational influences alone. If an object does not behave according to the natural forces acting upon it, then what is controlling it? One of the most famous cases is the interstellar object Oumuamua, first detected in 2017. Unlike any asteroid or comet observed before, it moved through the solar system at a speed and trajectory inconsistent with standard celestial mechanics. It displayed an acceleration that could not be explained by gravity alone, as if some unknown force were affecting its motion. Its elongated shape, lack of a visible tail, and the absence of expected emissions led some researchers to speculate that it was not a naturally occurring rock, but possibly an artificial construct, an object designed with a purpose beyond human understanding. Some theorists have suggested that Oumuamua was not just an anomaly, but evidence of an advanced propulsion system, one capable of manipulating space-time in ways that remain unexplained. If an advanced civilization had the ability to harness the properties of space itself, then its technology would not need conventional fuel or propulsion. It could simply manipulate gravity, inertia, or even time itself to move. This would explain why the object appeared to accelerate despite the absence of external forces. If extraterrestrial technology is capable of altering spacetime, then humanity may have already encountered it without recognizing what it truly was. Beyond moving objects, there have also been reports of deep space signals that suggest an intelligence behind them. Some transmissions have repeated with a level of structure that does not match natural sources. While many such detections have been attributed to pulsars, cosmic radiation, or interference, a few remain unexplained. If there are objects in space designed to communicate, then they may be operating on principles that differ from anything humans have encountered before. The concept of alien technology influencing space-time is not purely speculative. Within known physics, the warping of time through gravity and velocity is well understood. If a civilization had mastered the ability to generate artificial gravitational fields, then it would have control over time as well. This would mean that, rather than moving through space in the way humans understand, an advanced spacecraft could instead manipulate time itself to travel vast distances. Instead of accelerating, it could remain stationary while altering the flow of time around it, appearing to move faster than light by shifting its place in the fabric of spacetime itself. If such technology exists, then remnants of it may still be out there. There could be ancient devices, structures, or mechanisms drifting through the void, no longer active, but still holding traces of their former purpose. Some researchers have proposed that certain anomalies in the cosmic microwave background radiation, the afterglow of the Big Bang, may not be random, but instead the residual effects of past civilizations tampering with the structure of the universe itself. If intelligent beings had the ability to manipulate the fundamental forces of space-time, then the traces of their actions may still be imprinted on the cosmic fabric. There have also been theories regarding the existence of megastructures, artificial constructions on scales that dwarf planets and stars. Some suggest that unexplained fluctuations in starlight could be the result of massive structures orbiting distant stars, possibly remnants of civilizations that once harnessed energy on an incomprehensible scale. If these structures had the ability to manipulate gravitational forces, then they could also alter the passage of time within them, creating regions where time moves differently from the rest of the universe. Another unexplained anomaly is the sudden disappearance and reappearance of certain cosmic bodies. If extraterrestrial technology were capable of manipulating space-time, then it could theoretically move objects between dimensions, or even shift them into states where they are no longer detectable. There are recorded cases of astronomical bodies that have seemingly vanished from observation, only to reappear much later, without a clear explanation. If some of these are not natural occurrences but the result of technological intervention, then the implications are profound. One of the biggest questions surrounding the idea of alien space-time technology is whether it has already interacted with human history. If advanced civilizations have ever visited Earth, then they may not have arrived in ways that conform to human perceptions of time. A sufficiently advanced being, capable of manipulating time and space, would not necessarily need to travel linearly. It could enter a timeline at any point, making it impossible to track its movements in conventional ways. There are even theories that some of history's great mysteries, the sudden rise of civilizations, unexplained technological advancements, and ancient legends of gods descending from the sky, could be linked to beings with control over time itself. If such entities existed, they would not need to communicate in ways humans understand. They could exist outside of normal cause and effect, appearing and disappearing across history as they pleased. If alien artifacts are out there, then the question is not just where they are, but whether humans would even recognize them if they were found. A civilization capable of altering space-time would likely not build technology in ways familiar to human engineering. Their structures, devices, and even their very forms could operate on principles completely beyond the human ability to detect or understand. It is possible that some anomalies observed in space are artifacts of such technology, but without the right framework for interpreting them, they remain unsolved mysteries. The presence of alien space-time technology would also challenge fundamental ideas about human existence. If beings with such abilities have interacted with the universe, then what does that mean for the concept of reality itself? If time can be manipulated, then the past, present, and future may not be as fixed as they appear. If the universe has already been shaped by forces beyond human understanding, then the very foundation of human knowledge may be incomplete. One final question lingers. If such technology exists, if artifacts of advanced civilizations are still drifting through space, then is it possible that something or someone is still using them? If the universe has been altered by hands unseen, then those hands may not be gone. They may still be at work, shifting the structure of time in ways that remain unnoticed. If such forces are still active, then what are they shaping next? If the universe contains traces of intelligence beyond human comprehension, if technology exists that can alter the flow of time, then what happens when cosmic events begin to repeat? What if the universe itself has a memory, an imprint of past moments that refuse to fade? Some celestial phenomena do not behave as one-time occurrences. Some seem to replay, as if the cosmos itself is caught in a loop, echoing its past in ways that defy simple explanations. There have been cases where light from a distant star or explosion has been observed more than once, appearing at different times but originating from the same event. These are known as light echoes, strange repetitions where photons take multiple paths across space, bending around gravitational fields in ways that create delayed replays of past cosmic occurrences. A supernova that exploded millions of years ago may appear again as its light takes an alternate route, emerging in different locations across time. One of the most well-documented examples of this is the Einstein cross, a phenomenon where light from a distant quasar is split into multiple images by the gravitational pull of an intervening galaxy. These images do not appear simultaneously. Some arrive later than others, as if the same event is being played out on different timescales. The delay between these occurrences suggests that time itself can be stretched and rearranged depending on the structure of space. But there are stranger cases where events do not just appear to be delayed, they seem to occur again in ways that suggest something deeper is at work. Some astronomical anomalies involve explosions or celestial movements that recur not because they are cyclical, but because they appear to be the same event repeating itself under circumstances that do not align with known physics. These occurrences are difficult to classify, as they suggest that time is not flowing in a single direction, but is instead capable of folding back on itself, creating echoes of the past that persist beyond their original moment. Gravitational lensing, the bending of light due to massive cosmic structures, has revealed some of these anomalies. There have been instances where a light source appears in one location, only to appear again elsewhere, its journey altered by the unseen distortions of space-time. Some of these events have been explained by the natural warping effects of massive galaxies, but others remain unexplained. In certain cases, the same object appears more than once in a way that does not conform to standard models of lensing, as if the light is not just bending, but being replayed across different moments in time. One of the strangest implications of these echoes is that they raise questions about whether the universe itself operates according to a form of recurrence. If light can take multiple paths, arriving at different times, then what about the larger structure of reality? Some physicists have proposed that the universe may not be a one-time event, but something that undergoes cycles, expanding, collapsing, and then expanding again in a continuous sequence. If this is true, then some of the echoes observed in space may not just be reflections of past light, but fragments of previous universes, imprinted onto the current one. There is also the possibility that time itself is not as linear as it seems. If certain conditions allow for the replay of events, then there may be moments where space-time allows glimpses into the past or even the future. Some researchers have suggested that certain cosmic anomalies, such as unexplained flashes of radiation or sudden appearances of previously unseen objects, may be instances where the past momentarily overlays the present. Another unexplained phenomenon is the recurrence of identical patterns in cosmic structures. Some distant galaxies appear to have near identical twins in other regions of space, configurations that are so similar that they raise the question of whether they are separate entities or the same one appearing in multiple places due to distortions in time. If space-time can curve back on itself, then these repetitions may be more than coincidences. They may be reflections of the same structures existing across different moments in cosmic history. There are also questions about whether some of these cosmic echoes extend beyond light into other forms of cosmic activity. Some pulsars, which act as natural cosmic clocks by emitting precise radio pulses, have displayed erratic behavior, sudden shifts in timing that suggest something is interfering with their expected cycles. If time can loop or echo, then some of these pulsars may be caught in repeating sequences, sending signals that appear to originate from the past. There have also been instances where radio signals from space appear to repeat themselves, not as part of a known cycle, but in ways that suggest they are echoes of a transmission that has already occurred. While some of these signals have been linked to natural cosmic processes, Others remain unexplained. If time can create reflections of light, then could it also create echoes of sound and energy? Another perplexing anomaly is the presence of unexplained cosmic flashes, brief bursts of radiation that appear suddenly and then vanish. Some of these bursts have been traced back to specific events, such as collapsing stars or gamma-ray bursts, but others have no clear origin. In some cases, similar flashes have been recorded multiple times from the same location, as if the event that created them is occurring more than once. One of the most unsettling possibilities is that some of these echoes may be evidence that the universe itself is not as stable as it appears. If time can fold, stretch, and repeat, then what does that mean for reality itself? Could some events be caught in loops, replaying endlessly without ever breaking free? If light, gravity, and radiation can all be subject to these distortions, then the fundamental nature of time may be far more fluid than previously believed. There is also the question of whether these echoes could provide insights into the deeper structure of the universe. If certain events are repeating, then understanding why they do so could reveal new aspects of physics, perhaps even clues to the existence of multiple dimensions or alternate realities. If some of these echoes are not merely repetitions, but shifts in space-time itself, then they could be evidence of phenomena that exist beyond human detection. There have also been proposals that some cosmic echoes could be artificially generated. If a civilization had the ability to manipulate space-time, then it could, in theory, create intentional echoes, sending messages through gravitational distortions or bending light in ways that allow information to persist across multiple time frames. If such technology exists, then it may already be in use, leaving traces that remain undetected, simply because the framework for interpreting them has not yet been developed. Some have suggested that these repeating cosmic events may be part of a larger structure, a hidden rhythm in the fabric of the universe. If cosmic history is not entirely random but follows certain patterns, then these echoes may be hints of an underlying order, something that governs reality in ways that are only now beginning to be understood. If the universe does replay itself, then the question is not just whether this has happened before, but whether it will happen again. If cosmic cycles exist, then the events being observed now may be precursors to a larger repetition, a future in which the same moments unfold again in ways yet to be recognized. If the universe is capable of echoing its past, then what does that mean for the present? If time can repeat, then how many times has this already happened? And if these echoes are more than mere reflections, if they are signals of something larger at work, then what is the universe trying to reveal? If the universe has a memory, if events can echo across time, then what happens when the cosmic clocks themselves begin to change? Some celestial bodies serve as nature's most reliable timekeepers, pulsing with such precision that they rival the most advanced atomic clocks on Earth. Yet even these cosmic beacons are not immune to mystery. Pulsars, the rapidly spinning remnants of once massive stars, should be predictable, their pulses arriving like the ticking of an eternal clock. But sometimes these pulses shift, break pattern, or disappear entirely, defying every known law of astrophysics. If the most stable objects in the universe can slip, then what does that mean for time itself? Pulsars are among the most fascinating objects in the cosmos. They are neutron stars, the collapsed cores of supernovae, so dense that a single teaspoon of their material would outweigh a mountain. As they spin, they emit powerful beams of electromagnetic radiation, sweeping across the universe like celestial lighthouses. The precision of their pulses is extraordinary, allowing astronomers to use them as cosmic clocks to measure distances, detect gravitational waves, and even search for planets beyond the solar system. But for reasons that remain elusive, some pulsars have displayed irregularities, glitches in time itself. One of the most baffling anomalies is the sudden speeding up or slowing down of a pulsar's rotation. These shifts, known as pulsar glitches, occur unpredictably with no clear cause. Some theories suggest that these glitches result from internal changes within the pulsar itself, perhaps due to shifts in the dense, superfluid matter beneath its crust. But there are cases where the timing changes are so abrupt and extreme that they suggest something far stranger is at play. Even more puzzling are the pulsars that stop pulsing entirely, only to resume later as if nothing had happened. These intermittent pulsars are among the most mysterious cosmic phenomena. Some vanish for days, weeks, or even years before returning with the same steady rhythm they once had. There is no clear reason for these disappearances. If pulsars are nature's clocks, then what is causing them to miss entire cycles, only to return perfectly in sync as if no time had passed for them? In some cases, pulsars have been observed to shift their frequencies in ways that cannot be accounted for by known physics. Some appear to pulse at one rate, only to suddenly begin emitting signals at an entirely different rate with no known external influence. If time is consistent, then why would these cosmic clocks suddenly change their ticking patterns? There are even recorded cases where two separate pulsars, located light years apart, have experienced nearly identical shifts at the same moment. The odds of this happening by chance are astronomical, raising the question of whether an unseen force is acting upon them in ways not yet understood. If pulsars can be influenced by something beyond their immediate environment, then what does that say about the larger structure of time and space? Another layer of mystery comes from the way pulsars interact with gravitational waves. Some pulsars have shown unexpected timing variations when waves from distant cosmic events pass through them, as if time itself is being stretched and compressed. While general relativity predicts that gravitational waves should cause subtle shifts in timing, some pulsars have exhibited distortions far greater than what physics currently allows. This raises the possibility that some external factor, perhaps linked to dark matter, cosmic strings, or even unknown forces, is distorting their pulses in ways yet to be discovered. There are also pulsars that appear to be moving in ways that contradict their expected trajectories. Some have been observed accelerating toward regions of space with no clear gravitational source, as if they are being pulled by something invisible. If pulsars are being affected by unknown forces, then their changes in motion and timing may be symptoms of deeper cosmic distortions. One particularly eerie anomaly involves pulsars that emit unexpected bursts of radio waves before shifting their timing patterns. Some of these bursts have contained structures that hint at an unknown order, patterns within the pulses that defy randomness. If pulsars are cosmic timekeepers, then these patterns may hold hidden information, possibly encoded into the very nature of time itself. Another strange discovery is that certain pulsars seem to flicker in and out of existence when viewed from different angles in space. Some appear to be pulsing normally when observed from one direction, but vanish when viewed from another. This suggests that some pulsars may be interacting with hidden cosmic structures, perhaps gravitational distortions or space-time anomalies that alter how their signals are received. There have even been suggestions that some pulsars may not be purely natural objects, but remnants of something more advanced. Some astrophysicists have proposed that highly regular pulsars could be artificially created, either as navigational beacons by an advanced civilization or as energy sources beyond human comprehension. While this idea remains speculative, it raises profound questions about the true nature of these cosmic timekeepers. There are also rare cases where pulsars have emitted pulses that appear to contain additional layers of structure. These pulses do not match the expected electromagnetic signatures of natural pulsars and have left some researchers wondering whether they might be signatures of some unknown process, or even messages encoded within the fabric of time. If pulsars can be used to measure cosmic time, then could they also be used to store or transmit information across the universe? Another disturbing anomaly is the rare instances where pulsars seem to momentarily reverse their spin. While this should be impossible given the conservation of angular momentum, some pulsars have been observed exhibiting rotational shifts that suggest something is interfering with their motion at a fundamental level. If time itself is malleable, then these changes in spin rate could be symptoms of much larger distortions in the cosmic timeline. The existence of pulsars that exhibit chaotic timing irregularities also raises the question of whether time is truly as constant as it seems. If pulsars can shift, flicker, and vanish without warning, then the very nature of timekeeping on a universal scale may be less stable than previously believed. The idea that time flows at a fixed rate everywhere in the universe may be an illusion, one that pulsars are exposing with each unpredictable shift in their ticking. Some of the most extreme pulsar anomalies involve cases where they appear to slow down and then resume their normal speed at precisely calculated intervals. These occurrences are so exact that they suggest an underlying order, one that hints at a hidden structure in the way time unfolds. If pulsars are interacting with something beyond conventional physics, then they may be revealing glimpses of a reality that extends far beyond what is currently understood. The biggest question remains unanswered. Why do some pulsars exhibit these changes while others remain stable? If external forces are responsible, then why are only certain pulsars affected? Could it be that some regions of the universe are subject to greater time distortions than others, or that certain pulsars are positioned near hidden cosmic anomalies? If pulsars are slipping in and out of alignment with time itself, then what is causing them to fluctuate? Could they be responding to changes in the fundamental nature of the universe? An unseen cosmic force altering time on a grand scale? Perhaps the strangest possibility of all is that pulsars are not merely measuring time, but are, in some way, shaping it. If these celestial clocks are more than just remnants of dead stars, then they may be interacting with the universe in ways yet to be uncovered. If the ticking of a pulsar can shift, then what else in the cosmos is shifting along with it? If even the universe's most reliable timekeepers can fail, then what does that say about time itself? If the most stable objects in existence can slip, pause, and restart, then is time truly constant? Or is it just another fragile illusion waiting to be broken? If cosmic clocks can shift, if pulsars, once thought to be the most precise timekeepers in the universe, can suddenly speed up, slow down, or fall silent without explanation, then time itself is not as steady as it seems. But what happens when these irregularities occur, not in single stars, but across entire galaxies? What if time is not flowing at a uniform rate throughout the cosmos, but instead moving faster or slower in different regions? Some galaxies appear to have aged far beyond their expected lifespan, while others remain mysteriously young despite existing in the same era. If time can be stretched, compressed, or broken at a fundamental level, then the very structure of the universe may be more fragmented than anyone had ever imagined. Galaxies are meant to evolve according to a predictable process. Stars are born, shine for billions of years, and then burn out, leaving behind remnants that continue to shape the structure of the galaxy. But in some parts of the universe, galaxies seem to have accelerated through this process at an impossible rate. Observations have revealed clusters of galaxies that appear significantly older than their surroundings, filled with dead or dying stars despite being in regions where young galaxies should dominate. This raises a troubling question. Are these galaxies truly aging faster, or is time itself behaving differently in these locations? One of the most perplexing discoveries in modern astrophysics is that some galaxies appear fully mature despite existing in what should be a young part of the universe. According to current models, galaxies in the early universe should be chaotic, still forming, filled with young, energetic stars. Instead, astronomers have found galaxies that already appear to have passed through billions of years of evolution, while others nearby remain in a much earlier stage of development. If time were flowing at the same rate everywhere, this discrepancy should not exist. One possible explanation is that gravity itself is influencing the passage of time in ways beyond what is currently understood. Einstein's theory of general relativity states that time slows down in stronger gravitational fields. This has been observed on small scales, such as near black holes or even within our own solar system. But what if some galaxies exist in regions where gravity has had a long-term effect on time, causing them to age at an accelerated rate relative to their surroundings? If time is not a constant, then different parts of the universe may be experiencing vastly different rates of evolution. There are also anomalies where galaxies appear younger than they should be. Some clusters have been found with an abundance of stars that have not yet gone through the aging process expected at their stage in cosmic history. These galaxies should already contain large numbers of dead or dying stars, but instead they resemble much earlier stages of formation. If time is moving faster in some regions, it may also be moving slower in others, leading to galaxies that remain frozen in an earlier era while their neighbors evolve rapidly. This idea raises another possibility that time itself may be influenced by factors beyond gravity. If dark matter and dark energy have properties that extend beyond their known gravitational effects, then they may also play a role in shaping the passage of time. Some theories suggest that certain regions of space could contain higher densities of dark matter, leading to distortions in both gravity and time itself. If dark matter interacts with time in ways yet to be understood, then it could explain why some galaxies appear far older or younger than they should be. One of the most dramatic examples of this effect comes from studies of ancient galaxy clusters that appear to be aging faster than the cosmic expansion model would predict. These clusters, containing galaxies filled with old, red stars, exist in parts of the universe where such structures should not yet exist. If time is not flowing uniformly, then they may be experiencing an accelerated timeline compared to the rest of the cosmos. Another strange observation involves galaxies that appear to exist in different stages of evolution despite being physically close to one another. In some cases, two galaxies within the same cluster will have vastly different populations of stars, one filled with young, bright stars, while the other is composed almost entirely of aging red giants. This suggests that time may not be synchronized even within localized regions, raising the possibility that time itself may be subject to variations on a galactic scale. There is also the question of whether these time anomalies are natural or if some unknown force is influencing them. Some physicists have speculated that the universe may contain regions where space-time behaves differently, possibly as a result of past cosmic events or interactions with unknown structures. If there are hidden forces shaping time, then the evolution of galaxies may be far more complex than previously thought. The universe is not what it seems. Every known law of time and space bends under the weight of its own mysteries. Galaxies aging too fast, pulsars skipping beats like broken cosmic clocks, signals whispering through the void from places unknown, and objects that vanish only to reappear as if they never left. Space is not silent. It echoes with anomalies that defy explanation, with distortions that challenge our understanding of reality itself. What if time is not a straight line, but a web tangled and frayed at the edges? What if cosmic forces beyond our grasp are pulling the threads of reality, shifting events, replaying history, or erasing it altogether, from the Bermuda Triangle of space to the dark voids where nothing should exist, from stars that vanish to black holes that consume time itself. We stand at the edge of knowledge, staring into the abyss, knowing there is more to uncover. And yet, for every answer found, 10 more questions arise. If time is not universal, then what is real? If some regions of space move faster or slower through time, then where does that leave our understanding of history, of causality, of existence itself? If ancient civilizations once grasped the secrets of time manipulation, could their remnants still be out there, waiting to be discovered? The cosmos is a puzzle with missing pieces, a story written in echoes, a phenomenon that refuses to be contained by human comprehension. And that is why we continue searching. Because every anomaly, every mystery, every unexplainable occurrence is an invitation to look deeper, to question further, to stand at the threshold of the unknown and dare to take another step. Now it's your turn. What do you think? Could time itself be breaking apart? Are these anomalies mere cosmic accidents, or is there something or someone behind them? Drop your thoughts in the comments below. I read every single one. And if this journey through the unexplainable fascinated you, if you want to continue peeling back the layers of reality, then make sure to subscribe and hit the notification bell. There are more mysteries to uncover. And trust me, you don't want to miss what's coming next. Until next time, keep questioning, keep exploring, and never stop looking beyond the veil of the universe.